Okay, in this video, we are going to go over some examples for lab 3. Example number 1 here, we are trying to implicit plot the equation and then find how many points have horizontal tangents. Once we find that, we will also need to find the equations or the tangent line for those horizontal tangents. Okay, so to start this question, we're going to name the equation as equal n. And since I know we are going to use implicit plot, so make sure you load the plots package by saying with parentheses plots here. And the implicit plot, you will need the equation here and some x and y value here. Greatly refined so we can get the a smooth graph. You can. Okay, so as a reminder, you can also look up the implicit DIFF on your own. The implicit DIFF will help us to do the implicit differentiation, which means it will help us get a dy over dx. Okay, so make sure you have y first, then x in the end. So that gives you dy over dx. If you switch your order, the answer will be different. Okay, then here I want to name the derivative as dy, so dy colon equal, then I do the derivative for the equation. This is the dy over dx. Okay, and then then we want to find the critical value when the derivative equal to 0. Sorry, let me take it back. So I want to find the x value when the derivative equal to 0. We all know when derivative equals 0, that means the slope of the tangent is equal to 0. In other words, that's the horizontal tangent line. That's the slope for the horizontal tangent line. Okay, so solve dy equals 0, comma x. So we got two values, square root of 3 and the negative square root of 3 over 3. So since we get two x values, so we need to substitute both value back to the equation so we can get the y values. So so what we do is say subs x equal xv1 means we want to use the first output of the xv line here, which means it's square root of 3 over 3. And I have second answer, so we will say xv2 bracket to make sure this is a bracket 2 to indicate it's the second output of the xv line. So once we do the substitution to the equation, we can solve for the y. Okay, so I did the substitution and the solving all in one line. So this gives me the first y value, and this gives me the second y value. When we substitute the first output for the xv and the second output for the xv. All right, once we know both x and y value, we can substitute both x and y value into derivatives, so we can double check is the slope equal to 0, which should be. You can do that, or you can to verify that give you the 0 slope, or you can skip this, because that's how we got those two values. Now, now we have both x and y value, we can substitute both value and the slope into the point slope formula, which we all know it's y minus y1 equal m times x minus x1. So substitute both value into this equation, all three values, y1 and m value, the slope, and also the x1 value. So so that gives us two tangent line, because we have two x value and two y value give us the same horizontal tangents. So basically the same formula from the point slope formula, and we basically substitute in the yv1, which is the name we have for each output, and the yv for when we substituting the first xv value. Okay, which means when I substitute the negative 0.3341 here, and m1 is 0 here, and xv1, which is square root of 3 over 3 here. Okay, therefore this is my tangent line. Similarly for the second tangent line, excuse me. And this almost the same thing. Make sure you have different names. This is tangent line 1, this is tangent line 2, and this is the second value, second point value, and the slope value. So give us the second tangent line. Now we have both horizontal tangent line. We can try to graph them together to see is that correct. And the graph is showing us this is two horizontal tangent line. Okay. Okay. All right, so that's about the first example. Now, the second example here is about how we can solve a system of equations. Say we want to solve x minus y equals 3 and x plus 2y equals 5 for x and y values. Maple, you can just use the solve command, SOLVE, parentheses, and then the way to type the system of equations is using the bracket symbol. So bracket, type of both equation in order, then comma, make sure you say bracket xy. Means we want to solve both x and y value. So here we go, we have the answer. Okay, it's almost like how we solve for equations. Now we have more than one equation, just make sure you have this bracket symbol here. And also, since we are solving for more than one variable, make sure you use bracket here so we can include the other variable you want to solve. Okay, now the third example here, similarly to the second example, we want to solve another system equation. However, for this case, you may also use the fsolve command, which will give you decimal values. Okay, so almost like the solve command, say instead we have fsolve here, and then type bracket both equation in order, comma, curly bracket xy here. All right, and make sure you have parentheses here and ends here to close all the commands. Okay, fsolve is outside the parentheses. So here we get the decimal values. So just for you to see, if you didn't know you want to use fsolve command, you can use solve command. For this case, we get this answer here. You'll be wondering what is that. So then you can try fsolve, which will give you a decimal values, which will be more straightforward to you. Okay, now the fourth example here, we have g of x function equal to x cubed minus x squared minus 5x. Then we want to find the relative maximum and the relative minimum interval of increasing and decreasing inflection point. So to start this question, we can, since we are talking about the function g of x, so let's name the g of x first by saying g colon equal x minus great sign, then type x cubed minus x squared minus 5 times x here. And then we can graph it. I would suggest you to graph it since we want to know where do we have relative maximum, relative minimum, and also the intervals of increasing and decreasing. So from the graph, we can clearly see we have a relative maximum around here and a relative minimum around here, somewhere around between x equal 1 or 2, somewhere here, right? And for the relative maximum is where x equal roughly -1, or maybe somewhere around. We will see. Okay, and also we can see the graph is increasing from negative infinity all the way to here, then decreasing from here to here in the middle, and increasing again from here all the way to the end, to the infinity. Okay, so now we have a quick idea about how the graph look like, and then we can start working on the accurate information. So how can we find the relative maximum and minimum? So this class, we can use the derivative to find the critical values, and that will give us possible maximum minimums. So let's do that. So to find the derivative, we will start with diff command. Diff parentheses the g of x, comma x. This gives us a derivative, first derivative. And since we're going to need to use the derivative again later on, I'm gonna call this as df. So name this as df. So later on, if I say df, means I'm referring to the derivative. You know, okay. Let me say dg instead, because it's a g function. Dg means derivative of the g function. Okay, and then the second derivative of the g function. So this line here, notice I have the $2 here. almost like derivative, but since we have this extra $2 means we're looking for the second derivative of the g function. Okay. So, and I'm naming my second derivative of the g function as d2g. So you know later on if I say that, that's the second derivative of the g function. Now, if I want to find out when do the function increase or when do the function decrease, all we have to do is solve dg greater than 0, means when the function is increasing. And dg less than 0 means when the function is decreasing. Okay, so, and also we can find the critical value by doing solve the first derivative equal to 0. Okay, so here we are. So we have the interval for increasing, which is -infinity to -1, and 5/3 to infinity. And for the decreasing interval is from -1 to 5/3. And the two critical value we have is 5/3 and -1. Okay, so once we have the two critical value, we can substitute both x value into the original function, g function. And here we say CV bracket 1 is referring to the first output, which is 5/3 here, and GCV bracket 2 is referring to the second output, which is -1. So substitution, we get the -175/27, and the second answer is 3. So we can see this is a relative minimum, this is a relative maximum here. Okay, so that's our conclusion point. Okay. And about the point of infraction, so I found this definition from your module 9 materials, so you can go back and double check. So to find the second, to find the point of infraction, we can use the second derivative, make the second derivative equal to 0, and there we can that x value is a point of infraction. No, sorry, that's the x value for that point. Okay, so I did this earlier. Let me just put it here. Let me, I don't need to do this over here. So it's this is for later on. Let me get rid of that so it's less confusing. So I want to do the second derivative here. Then now we are talking about the point infraction. Let's solve the second derivative equal to 0. Solve parentheses dfg equals 0, comma x. This will give us the the x value for the point of infraction. So I'm calling this POI, and it's giving us 1/3. Now we can substitute this value to the function back so we can find the y value. At the same time, you can also do solve for the second derivative greater than 0 and the less than 0, where you can find it where the function is concave up and concave down. Okay, so that's another way for you to find out where is the x. That point, the function has point of infraction, so it's the same thing. It gives us 1/3 as well. Okay, all right, so therefore we can conclude 1/3 -47/27 is the point infraction point for g of x. All right, so I hope this helps